Hi there, Math Rockstars. This video is going to take a look at factoring using a method I call products and sums. Some people refer to it as reverse foiling or distributing going backwards, but however you decide to name this process, we're going to be using trinomials in this method. So I'm looking at things with three terms. I put two up here, t squared plus 21t plus 108 and x squared minus 11x minus 26. So the people that refer to this as reverse foiling do so because we're going to end up with an answer, a group of factors with two sets of parentheses in both cases. So it's the reverse of this process. X plus 2 times 3x minus 1, where you'd have to multiply first terms and outside terms together, inside terms and last terms together to come up with an answer. X times 3x is 3x squared. X times negative 1 is negative x. 2 times 3x is a positive 6x. And 2 times negative 1 is negative 2. Combine like terms, I end up with 3x squared plus 5x minus 2. So that's foiling or distributing, but we are going to go backwards. We want to start with this answer and end up with something that looks like this. So all of our answers are going to have two sets of parentheses. I'm just going to go ahead and put those in right now, and we'll fill them in as we get a little farther on down the road. So this method is called products and sums by me because we're going to be looking for pairs of factors that give us a product and give us a sum. And we're going to be looking specifically at the constant term. So in the first case, the 108, and in the second case, the 26 or negative 26. Those are going to be our target numbers for products. Let me show you what I mean by that. Let's do that first one here, 108. I'm going to list out all the pairs of numbers that I can think of that will multiply to be 108, so factors of 108. And I'm going to do this in a pretty organized way so I don't miss any. I'll start off with 1 and then work up the list. So 1 times 108 is 108. And then I'll say, well, does 2 go into 108? Sure it does. It goes in 54 times. 2 times 54 is 108. Does 3 go in? Yes, 3 definitely goes in. A shortcut, by the way, for knowing whether 3 is a number that goes in evenly into another number is to add up all the digits. And if that number is something that's divisible by 3, the original number is divisible by 3. So looking at 108, 1 plus 0 plus 8 is 9, and 9 is divisible by 108, 9 is divisible by 3. So I know that 108 is also divisible by 3, but in any case, that's if you don't have a calculator, and you probably have a calculator nearby so you can verify that 3 times 36 is 108. Does 4 go into 108? Yes, it does. 4 times 27. 5 doesn't go into 108, right? It's not ending in a 0 or a 5. 6 does go into 108. 6 goes in 18 times. And 7 doesn't, 8 doesn't, but 9 does. 9 goes in 12 times. 10 doesn't go in. 11 doesn't go in, but then 12 does, and then I've hit the other side of my list, and I know I've got them all. So that's a lot of numbers. You won't always have to generate such a huge list. But in this case, I've got, let's see, 1, 2, 3, 4, 5, 6, 7 pairs of numbers that will multiply to give us 108. I'm hoping that one of those pairs, if I add or subtract, this is the sum part, add or subtract, are going to give me 21. So let's look at that list. Well, 1 plus 108, nope, that wouldn't work. 2 plus 54, that would give me either 52 or 56. 3 and 36. If I add them, that will give me 39. If I subtract, 33. And I'm going down this list, and eventually I'm going to find, let's see, 9 and 12. Yep, I think that's going to be it. 9 plus 12. If I add those two together, 9 plus 12, that's going to give me 21. So that's going to be the group of factors that I'm going to use. The rest is easy. I take those factors and I plug them into my set of parentheses. Positive 9 and positive 12. And it'll be t and t. Let's just double check this, make sure that it's really working. We'll FOIL this. First, outside, inside, last. So my first terms are t times t squared. My outside terms, t times 12 is 12t. And that's positive. My inside terms are 9nt plus 9t. And my last terms are 9 times 12, which is 108. If I combine my like terms here in the middle, I'll end up with t squared. 12 plus 9 is 21, plus 21t, plus 108. Yep, definitely checks out. So the factorization of t squared plus 21 plus 108 is t plus 9 times t plus 12. Right here, done. Let's do the same process with x squared minus 11x minus 26. So I'm going to look for numbers that multiply to give me 26. And in this case, I'm looking at a negative 26. All right, let's see. I've got 1 and 26, 2 and 13, 3 doesn't go in, 4 doesn't go in, 5 doesn't go in, 6, 7, 8, nope, 9, 10, 11, nope, 12. I think I've got the list, the 1 and the 26. Now, because it has to be a negative 26, that means either my 1 or my 26 are negative. Either my 2 or my 13 have to be negative. They can't both be negative, because if I multiplied two negatives, I'd get positive 26 back, so only one can be negative. So I want to look and see which combination, one positive and one negative, is going to give me a negative 11x when I combine them. So negative 1 and 26, that would be 25. That's not negative 11. 1 and negative 26. That's going to be positive 25. Definitely not what I want, which is negative 11, that middle term. Negative 2 plus 13. Well, that'd be a positive 11. That's not exactly what I want, but very close. If I make the 13 negative, 2 minus 13, that's going to give me a negative 11. So this is the pair that I want, and I'm going to go ahead and fill them in. Negative 13 and a positive 2, and then x and x. And if I want to go ahead and FOIL it back out, I could double check, and I'll see that I'll end up with x squared minus 11x minus 26. In the next video, I'm going to show you what happens if your a is not equal to 1, like this one, 4t squared. It's basically the same process, but I'm going to use grouping as well. So that's how to factor a trinomial if you only have a 1 for a. And if you'd like to know how to deal with that 4, what happens when a is not equal to 1, then watch the next video.